Hello everyone, this student. I'm Mr. John, the computer teachers. So for this video, we will talk about chapter 4, linking between table. Okay, linking between table. So would you please go to the Google Classroom to download the notes and also the worksheet at the very beginning. Okay. Okay, now let's start to talk about this chapter. So this vocabulary description, that's relational database. Relational database. So what is the relational database? That is, it classifies the data and store them into some relevant table. Okay, so the more important part is uh, for relational database, we will try to store the data in some table. That means not only one table, okay, more than one table. All right. Uh, there are two main advantages of using relational database. One is it can reduce some data redundancy. Okay, and also it can increase the data consistency. Okay, so we will talk about these two advantages very soon. Okay, now let's take an example. So here we stored the data in a single table. Okay, only we use one table to store all the data. Okay, let's say here we have a table. It's called student. Okay, and here we only show you 7 records. Okay, with 8 field. Okay, 1, 2, 3, 4, 5, 6, 7, 8. 8 field. 1, 2, 3, 4, 5, 6, 7. 7 data. Okay. So first of all, we will talk about the reduction of data redundancy. So it's concerned about the file size of the whole database. Okay, the file size. Okay, so we try to calculate the file size of this database now. All right. So here is the state table structure given to you. All right. So we just try to calculate the uh, table size. Okay, and here talk about that. Actually, you can see from the data there is some data, okay, which is called, we call it some redundant data. Okay, maybe we can find some way to reduce the storage of this data. So you can see here the school name. Okay, 保良局馬錦明附中先中學 is very very long, but you can see it stored for 4 times. Okay, and another school name, 世界第一原展能中學 for 3 times. Okay, moreover, also the school address, also the school telephone number. Okay, all of these data are stored for more than 1 time. Okay, so here we have only 7 records. But take an example, if there are thousands of records, you can see that these data will repeat a lot of time. Okay, so they will store and waste a lot of storage. Okay, so never mind. We try to calculate the table size first. Okay, so for the table size of student, so we calculate the uh, field size of each field. So here this is given to you the storage of each field. Okay, so we try to add them all. Okay, the first one is 5 and then 10 and 1, and then here we assume it is 1 byte for easy calculation. And then 3, and then 30, and then 40, and then 8. Okay, so here is the size of one record. Okay, one record. Okay, and then try to remind yourself, what should we multiply to? Multiply to 8, multiply to other number. Yes, remember, we should calculate by, multiply by the number record. Okay, so here we have 7 record. So we will try to multiply it by 7. Okay, so try to do the calculation. Okay, so it is 98 times 7 in byte. So it is 686 bytes. Okay. Okay, next page. So now we try to break the whole table student into two smaller tables. Okay, one is called student, one is called school. Okay, that is for the table of student, it's only store the data of the student. Okay, but for the school data, we simplify it to only store the school ID, SCH ID. So if we want to know, let's say 钟文飞, okay, which school he studying in? So you can find in 501 here to check 501. That's 保良公媽今日附近中福先中學. So you still can know that where the student study in the school. Okay. Okay, but for now we try to calculate the size of these two tables. Okay, so first of all, for the student table, so here we have the field, here we have the fields, the storage of the field of student. It's 5, 10, it's 1, it's 1, it's 3. Okay, so you can think about what should we multiply to. For the other table, this is for school. So we just add the field all together. Okay, that's it. No more field here. Okay, and also you can think about what should we multiply to. Okay? So actually, for student table, there has 1, 2, 3, 4, 5, 6, 7. We say there are 7 students here. So we should multiply it by 7. Okay? But for the field, for the table of school, here we have only 2 records. Okay, 2 records. So we just need to multiply by 2. Okay? So let's try to calculate the file size. So this is 140 bytes. How about this? How about the storage of the table? School. So this is 162 bytes. So we try to add these two values together. It will become 302. Okay, so you can see here, if we try to separate the table to two tables, altogether the total storage size will be 302. But in the first table, if we just store it in one table for the whole, it is 60686 byte. So you can see that it is much less than we store it in only one table. All right. So it explains to you that why we should break the table into some smaller table. Okay, because in the example you can see that we can try to remove some redundant data. Okay, redundant data. Okay, so it can reduce the storage of the database. And on the other hand, can you see any? Oh, oh. And also the second problem is when you need to update the data of some information. Let's say if I want to change the school telephone, okay, so actually if you may need to change it one by one, okay, but sometimes if you change it wrongly for only one data, that means there may have two different set of the same data. Okay, so let's say if I want to change the telephone number to 2109112, but you have forgotten to change one of this data, then the data there will have one data that is different to the other all. Okay, so it will make that confused, right? On the other hand, if we only stored the table like this, if you need to change the school telephone, that means you only need to change once. All right. So the all the data, okay, all the information, okay, the same data of all the record will be the same. Okay, it won't be affected. Okay? So let's talk about the consistency. Okay, data consistency. All right. So this is the explanation of this part. Okay.